use variation of parameters to solve the given system. So here the step you need to do in order to use that method. So first find homogeneous solution, then find non-homogeneous solution, and your final answer is equal to the combination of homogeneous part and non-homogeneous part. Okay, so here's the steps, the general steps, and I will walk you through it step by step. Okay, so first put this into A minus lambda I. What is A? Let's call this matrix A, and then subtract it with lambda. It gives you this matrix, and then you need to find its determinant, which gives you this one. Distribute this out, simplify it, and then set it equal to 0. Solve for lambda. You will get repeated eigenvalues. Plug 1 into A minus lambda I. It gives you this matrix augmented with 0. Okay, from the first equation, I find out that K1 is equal to K2. If I choose K2 to 1, then K1 is -1, vector K is negative 1 1, vector X1 is -1 1 times e to the t. Okay, so since you have repeated eigenvalue, you cannot use any other lambda to find another eigenvector. So what you need to do is to use the same matrix, but instead of augmenting with 0, now you augment it with vector K, the vector you just found. Okay, if I did that, I got P1 equals negative P2 minus 1/2. Okay, so for this matrix, I call this one K1, this one K2. For this one, it's kind of different variable, so I need to use a different variable as P1, P2. Okay, so from here, if I choose P21, then P1 is -3/2, then vector P is -3/2 1, then my vector X2 is equal to vector K times T e to the T plus vector P times e to the T. Then my homogeneous solution is equal to C1 times vector X1 plus C2 times vector X2. Okay, that's simple. Now let's go over the non-homogeneous part. So similarly, like A minus lambda I, first you need to put homogeneous solution in a matrix which I call phi of t. So this really is what left over when you exclude C1 and C2. So ignore these two. This from your first column, this from your second column. Okay. Now phi the determinant of phi of t. It gives you 1/2 e to the 2t. Then you need to find its inverse, which is equal to 1 over the determinant times this matrix, but we need to change something. So in the upward diagonal line, you need to multiply by -1. In the downward diagonal line, switch their positions. Okay. After you do the calculation, it gives you this matrix. Now let's find u prime of t, which is equal to inverse pi of t times f of t. What is f of t? F of t is this, what left over, what doesn't go with vector x. Okay, so inverse phi of t is this matrix, f of t is that matrix, 1 1. Okay, so here's the thing. When you multiply matrices together, stick with the order. Okay, do not switch the order, because this matrix times vector 1 1 is different from vector 1 1 times this vector. Okay, it's just a property of matrices. Okay, so when you multiply them together, it gives you this matrix. Simplify it, it gives you this one. Right, now it's time to find the integral of u prime. Okay, so take the integral of this one, it gives you this matrix. So down here I also walk you through how to solve for the integral of 40 e to the -t. Okay, so use variation by use integration by part method. Let u equals 4t, du equals 4, dv equals e to the -t, v equals e to the -t. Okay, and then work it out. Now after you figure out the intro of this one, simplify it, it gives me this matrix. Okay, so for non-homogeneous part, it is equal to phi of t times u of t. Phi of t is this matrix, u of t is what you just found. Multiply them together in this order. Okay, it gives you this matrix. Simplify it, you will get this one. Okay, and your final answer is equal to x of h plus x of p. Okay, that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.